Okay, welcome everybody to this talk introducing mathematics and statistics at Lancaster. My name's Paul Levy and I'm the Director of Undergraduate Admissions in the department. So I'm going to say a bit about our degrees, a bit about the content, something about how we teach, and towards the end I'll say something about the grades that we ask for. So let's get started. First, let me summarise the content of this talk. I'll discuss the question of why you might want to study mathematics. Then I'll move on to our approach to teaching mathematics and how you would learn mathematics at Lancaster. I'll say something about the content of our degrees. Really, the focus is on the mathematics side, so it's the content of the single major degrees or the maths content of any joint major degrees. And that includes the range of modules that we offer, though I don't give details here. Then I'll briefly talk about the feedback that we've received from recent graduates via the National Student Survey. And then to finish off, I'll explain the standard offers for our single major degrees, and I'll also talk about the combined degrees without going into details about each individual one. So this talk is just a brief taster. You can find out more information by downloading the undergraduate brochure, or you can get more comprehensive information by looking at the course pages on the university website or by asking a question on Unibody. So let me start with the most important question that you should ask before deciding to apply for a maths degree, and that is why would you want to study mathematics? Now, this question is first of all, I'm including statistics in mathematics here. So why would you want to study mathematics, including statistics? But let's just think about this question. So it's kind of similar to the question, why would you eat Marmite on toast for breakfast? If you don't like Marmite, then it would be silly to eat Marmite on toast for breakfast. But if you do like it, then it seems like a perfectly reasonable thing to have for breakfast. And so similarly, if you don't like mathematics, then studying mathematics is not a good idea. If you do enjoy mathematics, then certainly it's a good idea to consider it. Now, you need much stronger reasons to study mathematics than you would need to put something on your toast. But let's get that down first. So first of all, you should study it if you're interested in it. Now, that applies to any subject, but if you are interested in mathematics and you enjoy it, then you're in luck, because there are also some other reasons, sort of benefits of studying mathematics. So I'm sure you've all been paying attention to some of the stories that have been appearing over the last few months that use phrases like flatten the curve and exponential growth. And these are mathematical phrases, of course. And maths gives you a great understanding of the concepts lying behind those phrases. And it therefore gives you a great understanding of some of the things that are happening in the world around us, in our societies, and so on. So maths helps to understand the world. It's a conceptual framework which helps to understand an awful lot of phenomena in the world. Now, I also find it intellectually challenging and rewarding and enjoyable, and I hope you do too. But the other sort of final thing I'll mention, serendipitous thing, if you do enjoy mathematics and are therefore interested in studying it, is that it does have quite good career prospects. Now, I won't talk about the career prospects in this talk. There is another video available on the website where you can look at a talk on that. But just very briefly, mathematics has a sort of range of different career options. So it's quite a good choice at university if that's what you're, if that presumably is something that you're interested in. Okay. So what about the teaching at Lancaster? So the teaching of mathematics, and of course the teaching is the framework by which you will do your learning at Lancaster. So one of the main important ways that we teach mathematics is via the lectures. I should say before I start this page that I could have perhaps inserted an asterisk that said in a normal year. This talk is aimed at people who are thinking of applying to begin their studies in the autumn of 2021. And at the moment, we have every reason to believe that the 21-22 academic year will be a normal year. But obviously, we've had to make some adjustments recently and will be doing during the 2020-2021 academic year. So in a normal year, mathematics at Lancaster is taught. Each course has a certain number of lectures. Typically, that would be 3 or 4 lectures a week. And the lectures are often taken in large classes, especially in the first year or the second year. And so you're given a copy of the course notes, and the lecturer sort of goes through those course notes, usually in order, and elaborates on some examples, just some worked examples, maybe discusses a proof, and you will take notes based on what the lecturer has said. And so the lecturer is kind of going through the material and giving you a framework by which you then go away and do your own personal learning. But you don't really kind of start to get to grips with the subject until you start to do exercises and questions on that knowledge. And the workshops are the main sort of class that we organise, which allow you to get advice on how you're doing those exercises and to get some interaction with other students and with some of the teaching staff in relation to the exercises and the questions that are being set in the course. So the workshops are often, not quite always, but often once a week. And for most courses, they are once a week, 1 hour a week. And there will be 1 or 2 members of teaching staff who could be a graduate student, so a PhD student, or might be a lecturer, who will circulate in that room. It doesn't tend to be conducted from the front in the way that a lecture would be, but you will sit sort of doing some of the questions, maybe answering quiz questions. There might be some sort of interactive sessions led from the front, but generally speaking, you'll sort of work on your own and work through the exercises and the material which have been introduced in the lectures. And this is where you're really learning the material. Now, in relation to that, we also set a certain amount of marked work, and that marked work might be once a week or once a fortnight. And you submit this work for a small proportion of your final mark. Really, that's just a sort of mainly a motivation for you to get that work in. And that work is marked and usually handed back to you pretty quickly. So within a couple of days, a few days, that work should be handed back to you with a mark and with some feedback on anywhere that you're going wrong, or hopefully feedback that says, yes, this is all fine. And so this is the sort of main system that we have in Maths and Stats at Lancaster for interacting with the teaching staff, getting some sort of information about anything that you maybe found difficult, and you've got regular chances to interact in that way, and therefore to be sort of steered on the right course if you're going slightly off course. So that marked work is also very popular. We find consistently students are very happy with the amount of feedback that they get and with how quickly they get the feedback. So there are some other timetable classes, mainly in the first year. And the timetable classes, I've included 2 examples here in the first year. So firstly, we have problem solving classes. So these are slightly different from the workshops in that the material of the problems is usually not introduced in advance. And you are given something which should ideally be a bit unfamiliar to you. And you have to apply lateral thinking. And as the title suggests, some problem solving skills. It might be quite tricky for you to solve those problems, but hopefully it should be fun and challenging for you to solve those problems. This would typically be taught by a lecturer or a professor or something like that. And they will ask questions which might seem to you to be not very helpful questions. They're not going to give you hints, but they will sort of ask you questions that hopefully get you to think about these problems in a way that's productive. We call it kind of meta reasoning or meta mathematical skills. So they're asking you to kind of, why are you doing this particular thing, and how do you think this will help, and what have you done there? Maybe asking you to clarify some of the points where they think you're not sufficiently clear, and so on. And this is giving you the sort of broader problem solving skills, helping you to develop those. And that will be especially useful, well, firstly, outside of the degree, in whatever you choose to do in the rest of your life. But also as you go on with the more advanced material in the degree, more challenging questions will be set, and these might be ones that need you to think outside of the box and think about a problem in a new way. Okay, so that's problem solving. Now, we also have a number of computer labs in the first year, and these computer labs are sort of sessions where you get to sort of practice and get some advice about how you're applying certain computational techniques. Now, as you proceed in mathematics, you will find that computers become more and more important, especially on the statistics side. And it's essentially necessary to do statistics is to be able to apply computational techniques. At Lancaster, the main program that is used is one called R. And if you want to apply some operations to a data set, then you need some computer that's going to do that for you. So in the first year, in certain computer classes, and then in the second year in a module that I'll mention later on called computational skills, we give you opportunities to learn the computational techniques and the reasoning behind sort of elementary programming in order to study these data sets and so on. And so that's another example of a sort of timetable class that we organise. And these are the main ways. In addition, in later years in the degree, there are sort of project components and so on that might require you to attend supervisions with teachers or some other sort of group work classes and so on. But the lectures and workshops, the marked work and so on, these are the main ways that you would learn mathematics at Lancaster. Okay, so the next slide is on course content. And the three columns, as you can see, are the first year and the second year and then subsequent years. Now, for the second year, I've included the titles of all of the modules which we offer in mathematics on our single major degrees. For the first year, I've given the titles of almost all of them, but there wasn't quite enough room for all 10. And in the third year, it's essentially impossible to give you the titles of all of the modules. So I've given a sprinkling. First, to explain what happens in the first year. So the system at Lancaster is a minor system. And if you're studying mathematics or mathematics with statistics, so a single major degree, this means that 2/3 of your first year would be in mathematics and the other third would be in a minor subject. And there are certain sort of standard minors that are optional that are available for you, and most of them correspond to the subjects in the joint honours degrees that you can see on slide 8 or 9 later on in this talk. So 1/3 of your first year would be in a minor subject and 2/3 would be in mathematics. So if you're studying a joint major degree, then usually you don't get any choice about which minor to take. And usually if it's a joint major degree with mathematics, then 2/3 of your first year would be in mathematics as well, and the 1/3 remaining would be the other subject in your joint major. That's not quite always true, but I can't give complete detail about what you would choose. So if you would like to know more, then please ask one of our ambassadors on Unibody, or try to find out from the course websites, or send us an email to get more detail. Okay, so in the first year, the 2/3 which is in mathematics, roughly speaking, it's 1/2 kind of topics which you will probably have seen at A-level maths and or further maths. And so you can see that we've got titles like calculus and probability. Now these are subjects that you've already seen, but obviously we're not just recapping what you've seen at A-level. We will cover what you've studied previously, and then bring everybody past to sort of a common standard and go into a more advanced level in those topics like calculus and probability and so on. And then the other 1/2 of the maths in the first year, so that's 1/3 of the first year content that you would study, is in topics which probably will be less familiar to you. And so I can pick out a couple of module titles here. We've got convergence and continuity, and discrete mathematics. And these are in areas which may not be quite so familiar. They're about, for example, properties of real numbers, sets. There are much more axioms and proofs and so on. And it's more abstract university style mathematics. And we think this combination, half and half, is really good because you need both skills, both some of the things that you've already seen and the computational techniques and so on, but you also need the abstract reasoning and some of the more abstract knowledge of mathematics in order to proceed in the subject. Okay, now in the second year, for the single major degrees, this is the real core of the degree. So there is a part 1 and a part 2 in the undergraduate degrees at Lancaster, and part 1 is just the first year, part 2 is the second year and beyond, and the degree is classified based on the part 2 marks. So once you get to the second year, this is really the stuff that counts. The first year is for progression, and in the second year we establish the core of the mathematics degree. So this is kind of the bit that we expect everybody to have achieved at a certain level in order to come out with a degree in maths or mathematics with statistics. And you can see that we've got 8 module titles here, and 2 of them are in algebra, 2 are in analysis. We've got 2 in the area of probability statistics, and then 2 in a stream that you could call maybe transferable skills. So we've got project skills and computational mathematics. So those are the sort of 4 main areas that we think are essential in order to start tackling the more advanced topics that occur in the third year. And in the third year, you get completely free optional choice of 8 modules from a variety of different areas. So algebra, analysis, probability and statistics, and some other parts of pure mathematics, which probably don't fit under algebra or analysis. And so there are 4 examples of modules here that could be taken in the third year. Number theory and combinatorics are sort of not quite in algebra, they're kind of in the rest of pure mathematics. And we've got some advanced topics in statistics, and I've given 2 which are kind of in the applied area of statistics. So this is medical statistics and machine learning. So at Lancaster, we're very proud of the statistical component of our course. We think it's, especially for statistics, one of the strongest in the country. This has an impact on, for example, the range of career options that might be available to you, but it also allows you to apply your knowledge in areas that probably aren't available when you start out in the degree. So medical statistics and machine learning are examples of more advanced topics. So there is also a module on mathematics education for people who might want to consider doing teaching. If you stay on for the 4th year, so if you do an MSci degree, which would be a master's degree that takes 4 years, then you would also do a dissertation in your 4th year, and you would have a choice of other more advanced modules, another choice of 8 modules in that, while you would take 6 modules in addition to the dissertation in your 4th year. Okay, so there's a range of different topics, and if you're interested in more of the detail, then please have a look at our undergraduate brochure or have a look on the website for some of the list of courses that is available. Okay, if you're doing a joint major, so a combined major degree, then for most but not all of them, you would do all of the mathematics which is available in the first year. And then you would do 1/2 of the maths in the second year, and 1/2 of your modules in the third year would be in maths as well. I'll say a little bit more about that later on, but most of them follow that pattern, but not quite all of them do. Okay. Now, one of the main ways that we have of getting feedback from students, well, in this case, recent students, so graduates, is this thing called the National Student Survey. This is a survey of students after they graduate. And as you can see, I brought up some statistics here which highlight the very positive feedback that we've had from students after they've graduated. So the 2019 National Student Survey is the most recent one that we have access to. We have the data from. And as you can see, we've got very high ratings for overall satisfaction, intellectual stimulation, and being able to contact staff when they needed to. And the last one in particular, I think, fits with my view of the culture within the department, which is very friendly and open. And so, for example, lecturers are required to have office hours while they're lecturing, so they should be available for students to come and knock on the door. And every student is allocated an academic tutor, So that academic tutor will be a member of staff who can advise them about study choices and other aspects, sort of academic advice that they need for their course. So I think that the feedback does show consistently that students find the department to be very welcoming and to be a place where they can go and get advice about their studies. And another aspect, of course, is getting regular feedback on the marked work that I mentioned earlier, and that is certainly something that students consistently say they're happy with. Okay, that's the student survey. Now here's a very important slide, which is about the standard offers. So the easiest description of the standard offers I can give is for the single major degrees. So those are either mathematics or mathematics with statistics. There isn't a huge difference between mathematics or mathematics with statistics. It's just that if you want to do a certain minimum component of statistics, that's what you would need to do at least half statistics to do the mathematics with statistics degrees. You would need to do at least half statistics in your third year or your third and fourth years if you're doing an MSci, just to be absolutely clear about that. So for all of these single major degrees, both the BSc and the MSci, the standard offer is 3 A's. Now you have to have taken A-level maths, but we don't require you to take A-level further maths in order to be admitted. However, we do believe A-level further maths helps, and for that reason we make a slightly lower offer if you are studying A-level further maths. So in that case, you would receive an offer of 2 A's and a B. There is in fact a third way, or a second way, sorry, of reducing the offer, which can be added to the reduction for a further maths. And that's if you do one of these exams, either the test of mathematics, which takes place in November, or STEP, which will take place in June 2021. If you do well enough on either of those exams, then we can give you a further grade drop. So to an A and 2 Bs if you are studying further maths A-level, just to 2 A's and a B if you aren't. So the test of mathematics is still scheduled to take place in November. If you aren't sure what that is and what STEP is, then please do a Google search for them and find out. And we can also answer any questions that you might have about those exams. So there is a bit more detail in the undergraduate brochure about TAMUA and STEP and how they would, what threshold you would need to get a reduced offer. Okay, so those are the standard offers for the single major degrees. Now, on the last slide, I'm going to talk about combined degree programs. The standard offers for these vary. So for a number of them, they are the same as the offers for our single major degrees, but I'm not going to go through each one individually. So I think the best thing for you to do is to, if you're interested in any of these degrees, is to look up the web page for the course on the Lancaster University website. This is a list of the joint honours degrees that are combined honours degrees with mathematics and one or more other subjects. Most of these degrees follow a similar pattern with 2 exceptions. So one of them is the natural sciences degree that you can see in the middle there at the bottom of the middle column. So this is what's called a consortial degree. It's a degree with a number of different departments contributing, not just 2. You can do a natural sciences degree which has a big chunk of mathematics. So if, for example, you're studying chemistry and mathematics at A-level and you would like to do natural sciences, which is a combination of chemistry and maths, then that natural sciences degree might be an option. And if you're interested in that, then I would encourage you to go and look at the natural sciences section of the university website or the online open day website. So that one is slightly different from the rest. There's no fixed proportion of which subject you have to take. For all of the others, except for Morse in the bottom left-hand corner, the proportion of studies in the second year and beyond is 1/2 mathematics and 1/2 the other subject. So, for example, if you're studying mathematics and philosophy, then instead of 8 modules of mathematics in the second year, you would take 4, and you would take a similar amount and the same amount in terms of credits of philosophy, and something very similar would happen in the third year. And for most of these, but not all of them, you are required to take 2/3 mathematics in your first year, but that isn't quite true of all of them. So mathematics, operational research and economics is a very mathematical degree, and but formally it's only 1/3, about 1/3 taken in the mathematics department, mathematics and statistics. And so the rest, which is the operational research and economics, is very mathematical in nature. It's just that it's taught through Lancaster University Management School. So that's an area which is, if you're interested in the application of mathematics to society, then that's a possible option for you to consider. So the Morse degree is sort of application of mathematics to business and so on. So these degrees are grouped together. On the left-hand side, we've got the blue ones. These are joint with Lancaster University Management School. And we've got the green ones, which are in the middle, which are joint with other departments in the Faculty of Science and Technology. And finally, on the right-hand side, there is a group of joint degrees with the Faculty of Arts and Social Sciences. Now, there should, in time for 2021 entry, be another degree to add on the right-hand side, which is Chinese Studies and Mathematics, but the degree code for that hasn't been confirmed yet. So if you're interested in that, then please stay tuned. So come log back in later on in the summer to see our updated information about that, and it will be run on a very similar basis to the other languages and mathematics. So that's a list of the combined degree programs that we have. Okay, thank you very much for listening, and I hope I have an opportunity to talk to you or interact with you at least at one of either the online open days or one of the physical open days that should hopefully take place in September and October. Thank you very much.